Hey, geometry students. In this lesson, we're going to be working with something that is anything but straightforward. See, if this were straightforward, we'd be dealing with lines or line segments, but we're actually dealing with the curve around the outside of a circle. So, yes, it's easy, but because it's curved, it's not straightforward as we talk about arc length and the areas of sectors. Now, actually, this is pretty easy. If we can conceptualize exactly what's going on here just by thinking about what we're talking about with portions of circles in arc length. Now, I just want you to picture this arc around the outside of a circle. This is the minor arc AB. Remember, to name a major arc, if we were going to go the other way around the circle, we'd have to have 3 points that we name on the arc. We're just going to name these two. AB, talking about this small arc here. This small arc has a degree measure of m degrees. Now, those m degrees are a portion of the entire circle. The entire circle will be 360 degrees. So I'm only dealing with, when I'm looking at this arc, this is a fraction of the arc length around the entire circle. And I know the circumference around the entire circle is 2 pi r. This is only going to be a fraction of the circumference. What fraction? Well, does it make sense that the fraction that I'm dealing with is the degree measure m divided by the total degree measure 360? So all I'm going to do is take my circumference, 2 pi r, times the fraction of the circle I'm looking at, m over 360, and that will give me the length of an arc. I would calculate the area of a sector the exact same way. The sector of a circle, by the way, a sector is an area that's bound within a circle by 2 radii. So I make a radius, I draw another radius, and that's going to bound off an area of the circle. How much area? Well, that area is going to be a fraction of the circle. And I calculate the fraction the same way. If I know the degree measure of the arc that's bounded off by those 2 radii, I can take that degree measure, divide it by 360. That gives me the fraction of the circle that this sector is taking up. Multiply that times the area of the whole circle. So I'm going to multiply the fraction of the circle I'm looking at times the area of the whole circle. That should give me the area of that fraction. Area of the whole circle is just pi r squared. So my fraction times pi r squared gives me the area of this sector. All right, let's take a look at some practice problems and see how this works out in real problems. Find the length of an arc with a measure 125 degrees in a circle and a 12-mile radius, round to the nearest hundredth of a mile. Well, I'm just going to write out this arc length formula. So that's what this is here. Notice that I've plugged in the specific values that I'm looking for this. Okay, so 2 pi r times the fraction of circle m over 360. That's 2 times pi times 12 times 125 degrees over 360 is the fraction of the circle I'm looking at. So this is going to be the whole circumference times the fraction that I'm looking for. I'm just going to go ahead and punch all of these into a calculator. I get 26, and it's asking me to round to the hundredths place, so I'm going to have to record 0.18. I have to round that digit up. So this is going to be 26.18, and then to the nearest hundredth of a mile. So I know it's in miles. Let's just check my answer. Bam, there we go. Find the area of the sector to the nearest hundredth of a square inch. Okay, so this one's a little different because it's an area problem, but the exact same concept. All right, so this is going to be pi r squared. I'm just going to copy my pi from up here. Pi r squared. Okay. And then I need to do times m over 360. Well, I know r and I know m, so I'm just going to plug those values in. Instead of r, we're going to say 7.5. Okay, because it's 7.5 inches. And then instead of m, I know that I'm bounding off, let's see, this is just 35 degrees of this circle, so it's going to be 35 over 360. It is really hard. You almost have to work to do the order of operations wrong on one of these. So it's going to be pi times 7.5 squared. Let's just type this in. Pi times 7.5 squared times, and then let's see, it's 35 over 360. That should give me an area of 17.18, and I'm going to round that 8 down to just 8 because the next digit's a 0. 17.18, and this should be in inches squared as my unit label. And let's just verify that we did that one correctly. Answer should be here, 17.18. All right, now, the other thing that we may have to do in some of these problems is instead of calculating an unknown area or arc length, maybe we have to use the area or arc length to calculate the radius. Maybe there's something else we need to calculate. Find the radius to the nearest hundredth of a centimeter. All right, so same formula as up here, except this time I know my area and I need to calculate the radius. So it's going to be pi r squared times the measure of the arc that's cordoned off by those two radii. So this is going to be 101 over 360, and that's going to equal, so pi r squared times the fraction equals, in this case, it's 78 centimeters squared. Now, how am I going to solve this? Well, I am going to multiply 78 times the reciprocal of this fraction. That'll get this fraction off of the other side. So let's go ahead and show what that looks like. I'm going to leave my pi r squared over here for right now. And then we're going to say pi r squared equals, and it's going to be 78 times 360 over 101. I multiplied both sides by the reciprocal of the fraction. And then what I'm going to do is I'm going to divide both sides by pi. I'm just going to do that in this same step here. So I'm going to take pi and divide this side by it. There we go. And then the last thing we're going to need to do with my answer is take a square root of r. We'll do that just on the calculator and we'll figure out what r is. So 78 times 360 over 101 divided by pi. Let's see. We'll do this, 78 times 360 over 101 divided by pi. Again, you'd have to really work hard to get order of operations wrong on this one. Again, you'd really have to work hard to get order of operations wrong on this one. I'm going to go ahead and calculate that. I get 88.496, but I needed to do one more step because this is r squared. To find r by itself, I need to take the square root of this. I'm going to say square root of answer equals, and I get 9.41. I have to round this up because the next digit is 7. 9.41. R equals 9.41. We'll make that a lowercase r to be consistent. And that is my answer. Let's see, that's going to be measured in centimeters. And then finally, letter D. If a farmer wants his irrigation system cover an area of 2 square miles and his sprinkler rotates through 50 degrees, what is the diameter of a circular field to the nearest hundredth of a mile? So I'm looking for the diameter of the field. I'm not able to calculate diameter directly, but I can calculate the radius, and that's what I'm going to do. So I'm using the same technique I just used with a word problem now to calculate the radius. So I'm going to copy this, pi r squared. It's going to be times the area, times the fraction of the circle. So this is going to be times 50 over 360, and that's going to equal 2 square miles. All right, same technique as up above. So I'm just going to actually copy my work from up above here because I need to get r on a side by itself. To do that, you start by getting r squared on a side by itself. My area was 2. My circle fraction was 50 over 360, so I'm going to multiply both sides by 360 over 50, divide both sides by pi. So let's go ahead and do that on our calculator. 2 times 360 over 50 divided by pi. So this is going to be 2 times 360 over 50 divided by pi. That gives me 4.58, but I'm not done yet. I need to take the square root of that. The square root of my answer is 2.14, rounded down 2.14. So the radius is 2.14 miles. That means that my diameter must be double that, because it's always 2 times the radius, 4.28 miles. Hey, let's just see if we did those last couple of questions right. Letter C was supposed to be 9.41 centimeters, and then this last one, 4.28 miles. All right, that's how you work these types of problems. Make sure you keep these two formulas in mind. If you ever forget the formula, just remember you're multiplying either the circumference or the area by the circle fraction that you're looking at. And you can go ahead and work the problem set for next time.